All right, for this second video for the Chapter 3 content, I'm going to talk through Clark Hull's system. And Clark Hull wasn't quite as influential as Thorndike. Um, Thorndike was really a leading theorist, but Hull was influential in shifting eventually from behaviorism to cognitivism. And so I like his theory because it helps explain how did the field of psychology move from the behaviorist perspective to being able to appreciate that what we think and how we process information is important. So his theory is called a hypothetical deductive system, and I'm going to give you first off an overview of the system. So his goal was to develop a logical, scientific, and mathematical system that would fully explain human learning and behavior. And so he was really, again, one of these psychologists who really wanted to place psychology within the field of science, not to be just a armchair theory, but actually rooted in things like equations and stuff like that. So he developed 17 postulates. These are untestable statements about learning, but he also developed 133 theorems. These are specific testable claims and hypotheses. And then beyond that, numerous corollaries. So it was a very extensive, very detailed system for understanding behavior. And he described relationships among the many variables he sought and thought he focused on human behavior. And so he wanted to understand how do these variables interact. And he wanted to develop a grand theory of human learning. Again, this idea that these early psychologists wanted to explain everything with a single theory. All right, so, there we go. So who was he? Clark Leonard Hull lived from 1884 to 1952. So you can place him as a early 20th century theorist. His initial aspiration was to be a mining engineer, but he did go on to obtain a PhD in psychology from the University of Wisconsin. Early on, he was interested in things like human and animal aptitudes. He was interested in the idea of thinking machines, what we call robots or artificial intelligence these days. He was also interested in topics like hypnosis and the effect of tobacco on intellectual functioning. So he was had a lot of diverse interests. In 1929, he went to Yale as a research professor, and that's where he developed his hypothetical deductive system. And again, I think it's always important to place the theories within a historical time frame. So these 29 and 30s, you could think about what was going on, the Great Depression, things like that. And so, okay, so Hull you could place him in a way as a behaviorist, but he actually disagreed with Watson's rejection of unobservable events. So if you recall, John Watson argued that psychology should only be about the observable, because basically Watson argued that's what science is all about. Science is about studying things that can be measured and observed directly. But Watson was kind of wrong on that account. So Hull argued that physicists and chemists make inferences about things that they have not actually seen or observed. So things like gravity, force, atoms, molecules. Well, at that time they hadn't seen atoms and so they were inferring characteristics of the things that they'd be able to measure close to these things, but weren't actually able to measure them directly. So Hull argued just because we cannot observe them directly doesn't mean they don't exist, doesn't mean that they are outside of the realm of science. So Hull's system, he saw himself, if you recall, the behaviorists were stimulus response theorists. But Hull saw himself as a stimulus organism response theorist. So he was, and that's important, he was raising up the idea that the organism, how they perceive and how they respond to stimuli, is an important part of understanding behavior. So you can call him a neo-behaviorist. So he argued that the organism matters because they're processing the stimulus according to past experience, and they're using the processing to produce a response. Okay, so how do you think about this? Well, as a scientist, he wanted to sort of organize the understanding. So he argued that stimuli are a sort of input variable. So again, these are objective. Stimuli are observable. You can have a sight, a sound, a taste, a touch, etc. That objective element. And of course, the responses are objective. That is your output variable. And you can measure the behavior, you can measure the salivation, and things like that. And so, but there's a hypothetical, and again, this is why he called it a hypothetical deductive system, that exists between stimuli and response. He argued that there's a relationship between input and output variables. He called these intervening variables. So on a real simple level, just think about this idea of what if Pavlov's dog was deaf? Would that have mattered for his research? And I think the answer is, of course it would. You cannot classically condition a deaf dog to respond to a bell or a buzzer. And similarly, what if Pavlov's dog wasn't hungry? What if that dog was fully satiated and was no longer hungry? Would that dog still salivate to the response to the idea of food? So what Hull is doing is he's saying the characteristics of the dog do actually matter, and they do potentially impact the results. So this image, it's not perfect, but it does sort of summarize his system. So in the red box on the left, there are a number of variables. Again, these are the inputs. And this includes the number of prior reinforcements, the drive condition, the stimulus intensity, the amount of the reward. You don't need to know each of these, but just recognize that these are the observables. So how many times did you reinforce the organism? How intense was the stimulus? So if you're talking about a sound, how intense is the sound? If you talk about a light, how intense is the light? And how much reward was there? Again, that's an observable. If you're giving a reward for behavior, it matters if it's just a couple food pellets or if it's a full meal. So those are the input variables. But in the green in the middle, this is what is really important for Hull. You have these intervening variables. And so you have things like habit strength, drive, stimulus intensity, dynamism, incentive motivation. I'll talk about these a little bit in a couple slides. But you have some properties of the individual that determine how they react to those stimuli. And overall, that comes together into a reaction potential. And then you have the characteristics of the behavior. So you can have response latency. How long does it take for the organism to respond? What's the amplitude of the response? How strong is the response? And then what are the number of non-reinforced responses to extinction? Again, these are things that you can observe, and they are outcome variables. They're the output of the input. So what Hull actually was doing was trying to have a formula with all these, you see these letters beside each of those characteristics. You wanted to have a formula that you can say, okay, we have this variable, this variable, this variable, if you just plug in the actual number that goes with that variable, then you can actually accurately, ideally, accurately predict how a organism will respond. So in the sense, if you had all these variables, if you knew exactly how many prior reinforcements they had, what's the intensity of the stimulus, what's the amount of reward, you can actually predict the response latency, response amplitude, and the number of non-reinforced responses to extinction. So, okay, I'll walk you through this a little bit more. So first off is the input variables. Again, these are the things on the left. You can think about these as independent variables. They are what leads to a response, and they are what the experimenter can actually manipulate. So again, how bright is the light? How, what kind of stimuli are they presenting? Then you have the intervening variables. These are not within the control of the experimenter, at least not directly. But they're really important for understanding what Holt's theory is all about. So these intervening variables are properties of the organism, and I keep using organism because this applies to animals, it applies to humans, at least theoretically, and it's what he argues is these are what determine whether a response will occur for a stimulus. Again, something like a deaf dog will determine whether the stimuli can lead to a response. So again, the organism's characteristics. And the most important of Hull's intervening variables were habit strength. Okay, how strong was the already existing habit that they had, drive, stimulus intensity dynamism, incentive motivation, and reaction potential. And I'm going to walk you through a few of these. So yeah, let me show you that. First off, habit strength. Really, this is just understanding how many times has the stimuli been paired with a response. Well, basically, if you have a strong pattern, if the stimuli has been paired with the response, again, that could be observable. But really, it's about what's inside the individual. How strong is that connection that they already have? Secondly, is drive. Drive is asking this question, is the response connected to a reduction in a drive? So you may be familiar that we have a number of primary drives like food, safety, and sex. Those are basic human needs. And then we have a number of secondary drives, things that motivate us because they're associated with primary drives. So for instance, money is a secondary drive. We have a motivation to pursue money. Why do we like money? Well, we associate money with food, with safety, with desirability. So there's an association even with sex, and that's what underlies our drive for money. So as an example, to kind of help you understand this, here we have a fat rat. This rat has already eaten, is full, and you can kind of imagine, all right, if you're trying to get a rat to navigate a maze, but that rat is already full, then they're not going to be very motivated by additional food to navigate that maze. So this is, again, one of those important things to consider if you're trying to understand behavior, animal behavior, human behavior. It's really going to ask, okay, is this human or animal? Do they have a drive inside of them to that they're seeking to reduce? So if you're trying to get people to study for an exam, do they have a drive to study? Do they have a drive for the knowledge? Do they have a drive for the grades? If you have a student who doesn't have a drive to learn, doesn't have a drive to get good grades, then they're not going to be, you can offer that to them. You can say this will make an impact on your grade. This will lead you to learn more, but they may not actually engage in the studying because they don't have the drive. And what Hull did is he said that's an important element. The other intervening variables, well, we have stimulus, intensity, dynamism. It really has to do with how intense the organism perceives the stimulus to be. So, there's times where you can turn your volume in your car to a certain level and, objectively it has a certain decibel. But if everything has been quiet, then you're not going to be, you might experience it, perceive it to be louder than if you just got out of a concert. You leave a concert, you turn up the volume in your car radio, and it may not seem all that loud because it, and that's kind of the idea of this dynamism. Then you have incentive motivation. It says, how do previous reinforcements change the incentive value of subsequent rewards? So an example of this, if you normally got $1 to clean a room, you'd be highly motivated if you were offered $5. On the other hand, if you normally got $20 to clean a room, you would not be very motivated if you were offered $5. Well, objectively, $5 is $5, and yet, what Hull is trying to appreciate is that the incentive motivation can vary, even though the objective reward is the same. So how you perceive it, how you compare it against other rewards you've gotten. And the fifth intervening variable is reaction potential. So the intervening variables influence the reaction potential. So it's like they funnel they have a potential to react. And here you can see that Hull has a formula for how do you calculate this. It was the habit strength multiplied by the drive, multiplied by the dynamism. Well, I'm blanking on the names of these. The stimulus, intensity, dynamism, and then the incentive motivation is the K. And so basically you multiply those together, and that will lead to a reaction potential. Now, again, this is kind of surprising for most students because they don't think about human behavior as equations, right? So we're used to seeing equations with physics, maybe with chemistry, in some ways with biology, but we're less familiar with psychology having equations. But really, that's what psychology is all about. It's about predicting behavior. So if you take certain things into account, that will lead to a influence on the behavior of the organism, the animal or the human being. And so what Hull is trying to do is say, can we predict what the behavior will be if we can account for these things? All right, and then finally you have the output variables. This is what you're trying to predict. This is the dependent variables. So basically what Hull was doing is saying, well, what are we looking at when we're looking at a behavior? We might be looking at response latency, how long it takes to respond. We might be looking at response amplitude, how much of a response is made, how much salivation is the dog producing. And then we might be looking at the reaction threshold. If the reaction potential is higher than this threshold, a response will occur. Okay, so again, that's the basic overarching input, intervening variables, output. You can also say stimulus, organism, response. But Hull had a few other ideas, just a couple that I'll go over. One of them was fractional antedating goal reactions. So you could think about this as a conditioned response made by an organism before the actual goal reaction. These are anticipatory responses. So let's say a rat is navigating a maze. So arriving at the food is the ultimate goal. But along the way, there are smells and sights that have been linked with the goal. So they produce a anticipatory response. So they're not at the end of the maze. They're not at the food bowl that they will get this reward, but they will experience it as a reward. They'll realize, well, I'm putting it in cognitive terms. They'll realize that they are along the way getting closer to the end of the maze, and that will give them a sense of pleasure and of satisfaction. So that's the idea of fractional antedating goal reactions, is that the process of getting closer to an ultimate goal is going to create a internal response, and that internal response will keep the organism going. Another important idea is the idea of habit family hierarchies. So there's this idea that as we learn, we acquire habits, and habits are just stimulus response bonds. And an individual will learn a number of different responses for the same stimuli. And in many cases, each response leads to the same goal. So let's say you see a bear. Well, you can, that's a stimulus, and that can lead to a variety of different behaviors. So the first behavior might be to run. But then you might realize that I cannot run away. So instead, you might resort to yelling. And the yelling is this idea, you're trying to get to safety, right? So you run to safety, or you can yell to try to get yourself safe. You could sing, you could pray, you could freeze, and you could try threatening the bear. And you start at the top, right? You have your preferred response. That's the one that is probably the most associated with the reinforced behavior, right? To get to safety, that's the reinforcement. Safety is the need that is being satisfied by running. And that's the start point. But then you can, it's a hierarchy. So in the case that that is not an option for you, you can try another behavior, try another behavior, try another behavior. And so it's just this idea that we organize our behaviors according to, well, he called it habit families. All right, so summarizing Hull's theory, it's basically saying behavior is lawful and predictable. And you could, if you know enough about the organism and about the situation, you can actually predict an organism's behavior according to mathematical equations. So the main purpose of the theory is trying to discover the relationships that exist between stimuli, input variables, and responses. And the goal is to be able to predict output given knowledge about input. But he recognizes you cannot do that without making some inferences about the organism itself. So it's not as important to know formulas. I'm not saying that for this class. You don't need to know any formulas for this class from Hull's theory. But it's really this idea that we're linking things together. That's what happens inside the organism, is that it's a link between input and output, stimuli and response, sensations and actions. Okay, now that's an interesting idea. So the last idea that I want to put forth, and this isn't in the textbook, but I think it's an important question for us, is what is the role of free will? So there are theorists, so these theorists, Thorndike, Hull, Watson, are arguing that our actions are a result of our environment. But of course, most of us are more familiar with this idea of free will, that we choose the way we act. And I just want to juxtapose those two perspectives. So you have the psychological behaviorist perspective that says that we are the product of our environment, that our actions are the product of our environment. And then you have others who argue that we are in control, we make choices, decisions, we have agency, is one way to put it, where you get to direct your own life. And there's again, a juxtaposition where they both cannot be right. At least the way I think about it, you cannot have both of those be correct. So one of the things I think that this course does is it causes you to rethink whether free will actually exists. Does this idea that you can make choices and direct your own life actually fit with what the science says? And again, that's a challenging idea. Now, I encourage you to reflect on what your own views are, but I actually prefer the term bounded will instead of free will. That I think we should pay attention to the science. I think we should acknowledge that the science has something to say. But I also think we don't have to completely give up this idea that we have agency at all. So there are some who do that, who argue that we are just, robots who we think we have choice, but we actually are just deluding ourselves. But I think it's a little bit towards the middle, where our actions are, of course, always shaped by our experiences. Our will is never entirely free, but I still want to hold on to this idea that we have some degree of responsibility for our actions, that we are asked to, in terms of my faith, we are asked to do certain things and we're asked to not do certain things. And in asking us to do that, there's an assumption that we have a choice, that we have some agency, some control over our own actions. And so when I think about this question, I say, well, we need to appreciate that environment shapes us and influences us. I think you just cannot get away from that idea. But I think it's interesting to try to consider this possibility that will might exist in a space, within this context of how we're shaped by the environment around us, to alter our behavior in sometimes some subtle ways, maybe sometimes some not so subtle, but some big ways. And I like to think that we have some capacity for choice. But again, I encourage you, one of the discussion forums asks you to think about this topic. And so I encourage you to, reflect on this and see where your views land. Okay, well, hopefully this was interesting to you. I'm going to wrap it up, and we'll move on to chapter 4.